Page 9 of lines. Number 7. The line L1 has equation 2x minus y plus 6 equals 0. Write down the gradient of L1. You have to be really careful with this format, 2x minus y plus 6 equals 0. It's this format here, which we call standard form. Standard form is not very informative. It doesn't really tell you anything right off the bat. It just maybe looks nice. So what we need to do first is to change this format into the gradient intercept form. And the difference between the two is the gradient intercept form has the y by itself on one side. So first thing we're going to do is we're going to try to put this y by itself on one side. Do you see how it's minus y at this point? What if, I'm going to rewrite the exact same equation here. And I need to add y to both sides in order to get it on one side by itself, because currently it is negative. One way to make it positive is to add y to both sides. So now I have 2x, and the minus y and the plus y cancel each other out. So I have 2x plus 6 equals y. And now I suddenly have it in gradient intercept form because y is all by itself on one side of the equation. Now I can figure out the gradient, because since it is in gradient intercept form, I know that the gradient is the number that's multiplied times the x, right? So that means that the gradient is 2. Write down the y-intercept of L1. Well, if the gradient is 2, then the y-intercept is the other number, which is 6. So I'm going to write that down. The point A, c, 1.5 lies on L1. Find the value of c. Okay, first thing we need to do is, since we have the equation written in gradient intercept form, we can already program it into the calculator, and that can give us a lot of information about other points that are on the line. So 2x plus 6 is the equation, right? And then I'm going to do second table, and then we see a lot of the points that are on the line. And what we want is, we want the point that has a y value of 1.5. And I don't see that here, right? So what if I increase the step size? What if I increase the step size to like plus 0.1? Now do I see any points with 1.5? And I don't, but I can see that right between these two, maybe there is a point. So what if I increase the step size to 0.01? And now I found it. So the x value that goes with it is negative 2.25. So there's a point which is negative 2.25 comma 1.5, and so the c value is the negative 2.25, the first coordinate of this pair. Okay. D. The point B, 5 comma t, lies on L1. Find the value of t. So this is a little bit easier. If they give us the x value, then it's pretty easy to find the y value. One of the ways is with the table, and let's do that first, okay? First of all, let me return the step size to plus 1. So I'm going to do second table set, and then I'll put 1 here. Okay, and then I'm going to do second graph again to see if we can find the 0.5 comma something. Oh, it didn't work. Wait, second table set. Oh, we're supposed to change the table start to 0, and then we're going to change the delta table to 1. I don't think I did delta table to 1. Okay, now I'm going to look for what is the y value when the x value is 5. It's 5 comma 16. Okay, so the ordered pair is 5 comma 16. And the t value would be 16. Line L2 is parallel to L1. Write down the gradient of L2. Okay, so if L2 is parallel to L1, it must have the same gradient, which is 2. Find the equation of L2 if it passes through 0, 4. Okay, so they gave me a point, which is 0, 4, and they tell me that the gradient of L2 is 2. I could use gradient intercept form if I knew the y-intercept, and wait a second, I do know the y-intercept because 0, 4 is the y-intercept, right? So if they give me 0, 4, that means the x-coordinate is 0, the y-coordinate is 4, and that's the y-intercept. The y-intercept is 4, which means the equation of this line is going to be y equals 2x because the gradient is 2, plus 4 because the y-intercept is 4. Let me find you a graphing method. Let me show you a graphing method to find the answer to C, okay, without doing that crazy technique that I showed you where I changed the step size to 0.01. There's another way to do it. Okay, we have 2x plus 6 here, right? And I would like to know when 2x plus 6 has a y value of 1.5. So here's another graphing method to do it. And the way you do it is you say you put the desired value for y here, 1.5, right? 1.5. And then I graph both of these lines. One of them is a horizontal line, which goes at height 1.5, and the other is the line 2x plus 6, right? So the way I can find that this value is actually negative 2.25, 1.5 is I can do intersect now. Second calc intersect 5. And then first curve, second curve, we just enter twice. And then the guess, it doesn't matter what it is either. So the intersection is negative 2.25, 1.5. Okay, just like we got using the table method. So you could either use a table method or you can program this desired y value as the second function y2, and then you see where they intersect. Okay, number 8. The line L1 joins the points 1, 2 and negative 1, 6. Find the equation of L1. Now remember, this appears with algebra to be one of the hardest possible linear equation questions, but remember, with the calculator, it's one of the easiest ones because all we need to do is program these two ordered pairs into the calculator, and the calculator will automatically give us the equation. So we'll put them into stat edit, and then we go to stat calc lin reg, which is number 4, and then we do the calculate. L1 and L2 are already there. Frequency list is blank. That's exactly what we want. And our equation is y equals negative 2x plus 4. Oops. Y equals negative 2x plus 4. Okay. Find the equation. So that's the equation. C is the point 10, negative 16. Decide whether A, B, and C are collinear, giving a reason for your answer. Okay, so the best way to do that is to program the equation that we know, which is negative 2x plus 4, in the calculator, and then we'll check the table to see if all these are collinear or not. So negative 2x plus 4 is the equation, and then I'm going to delete this one. And then I'm going to look at the table. And let's see, 1, 2, yes, that's in the list. Negative 1, 6, yes, that's in the list. So those two are collinear. What about C? C is 10, negative 16. Let's see what the value is that corresponds to 10. X equals 10. 10, negative 16. Yes, it is. Okay, so it says to give a reason for your answer, and so my reason is going to be that the XY table includes all three. The XY table for y equals negative 2x plus 4. So that's one way you could confirm it, right? All right. Exercise 3G, number 1. Write down the equations of these lines. Okay, remember that. I just darkened the lines here because when we print this out, it's kind of hard to see that these red lines are horizontal and vertical lines. So A, I drew a vertical line at x equals 3. Okay, so a vertical line at x equals 3 has, you could check to any point on the line, and you could always see that for example, this point here is 3, 3. This point here is 3, negative 3. And this point here is 3, 0. Do you see how the x-coordinate is always 3? 3, 3, 3. So actually the definition of a vertical line at x equals 3 is that x is always 3 and y can be anything. So the equation of this vertical line is x equals 3. So sometimes people get mixed up because x sounds like it's a horizontal line, but actually to define a vertical line, you define the x value and not the y value, because the y value can be anything, right? If you look at this horizontal line here, do you see how it crosses y equals 1? Well, it turns out that any point on the horizontal line has a coordinate pair where the x value changes, but the y value is always 1. So this is 4, 1. This is negative 4, 1. So you see how the y value is always 1? So when you have a horizontal line, it's defined by y equals something. In this case, the height is 1, so it's y equals 1. Okay, we just talked at the first problem about a way of using second calc intersect to solve the problem at the top. Now we're going to use it to just simply find the point of intersection between two given lines. So this is one of the easier things to do. 3x minus 6, delete. And then you put the second line in. It's going to be negative x plus 2. Make sure you use this button and not this button. Negative x plus 2. And then I graph both. And then they intersect. And of course I'm going to use second calc intersect, which is number 5, to find. And first curve, second curve, guess. I just hit enter 3 times because when you have linear equations intersecting, there's only one possible place they can intersect. So it doesn't really, you don't have to like sit there moving the cursor around to show which intersection you want. There's only one. And we only have 2 lines programmed in, so we just hit first curve, second curve immediately with the enter. The calculator can easily figure out which functions we want because there's only 2 functions in the calculator. So make sure that you just keep 2 functions in the calculator. When you do this, it makes the procedure much simpler. So the intersection is 2, 0. Okay? And what about this other double set here? And these are a little bit harder because to program these in the calculator, first we need to put them in gradient intercept form. We need y by itself. So, for example, we have negative x plus 5y equals 0. Let's add x to both sides so that we can get y by itself on the left. And then, unfortunately, y is still multiplied by 5, so we get rid of the 5 by dividing both sides by 5, and then we end up with y equals x over 5. So that's one of our equations. You may say, oh my gosh, what's the slope? There's nothing multiplied times x. But actually what you're multiplying times x is 1/5, okay? Let's do the other one. So this one here, y is kind of by itself here, so let's subtract 1/5 x from both sides. And then we'll have y minus 2 equals negative 1/5 x, because these two cancel each other out, right? Now we're going to add 2 to both sides. So we have y equals negative 1/5 x plus 2. So now we have this equation of a line, and we have this equation of a line. All we need to do is now put them in for y1 and y2 and do second calc intersect, and we can find the intersection between these 2 lines, even though they started out in a different form than gradient intercept. Now in this particular case, the reason why we want to put it into gradient intercept form is because gradient intercept form can be programmed easily into the calculator. Okay, so do you see how I programmed in the negative 1/5? I put parentheses, negative 1/5 x. Another way you can do it is you can use the math number up and d function. We can put negative 1 on top. We can put 5 on the bottom. We can multiply times x plus 2. So that looks a little nicer. Okay, so the two lines obviously intersect there. So we're going to do second calc intersect, which is number 5. And then we're just going to hit first curve, yes. Second curve, yes. guess yes, because there's only 2 functions programmed in the calculator, and there's only one intersection, so it's pretty basic. So the intersection point turns out to be 5, 1. Okay, and that's it for page 9.